Hi everyone, today we are discussing the topic of rounding numbers to decimal places. So, in our daily life, we actually round a lot of the values. We also call that approximating because sometimes we just either don't really care for the exact value or it's not possible to figure out the exact value in real time. So, for example, when you're driving your car and you're trying to figure out, how fast you're going, your car actually can't keep up and let you know exactly how fast you're going. So, they're going to give you an approximation or an estimate of how fast you're going, right? You can say, like, oh, I'm going about 20 miles per hour, but your car isn't telling you like 20.58 miles per hour, right? It's rounding it for you. So you can just kind of estimate how far or how fast you're going. The other situation where we don't exactly use an exact value is when talking about population. So, how many people are living in your country, for instance? Because A, it doesn't really matter whether you find the exact figure. And B, it's also like really hard, right? Because as soon as you say, hey, there's this many people in the United States, maybe somebody just got born or someone passed away. So it's very hard to find the exact value at that moment. So we do use approximations a lot in our daily life. All right, before we get started with talking about rounding to decimal places, let's first review our different place values. So up until now, you probably have been very familiar with just your whole number place values. So you know to the immediate left of the decimal point are your ones place. Then next over is your tens place, hundred place, thousands place, 10,000s, 100,000s. Okay, most people are pretty good about those first six. Then it starts getting more complicated. Then we have millions, 10 millions, 100 millions, and then billions. It does keep going, but for the sake of this exercise, we're only going to get as big as the billions, okay? Now, for your decimal place values, they get a little more interesting because they don't necessarily follow the same pattern of names as it is with the whole numbers. So let's review those. To the right hand side of the decimal point, you have your tenths. So you notice that you have your TH additions to all of these place values. Tenths. Because we're talking about a fraction amount, not a whole amount. So you have the tenths place, the hundredths place, thousandths place, 10,000s, 100,000s, and then millionths. If you need to, make sure that you write this down in your notebook. All right, now let's review the rounding process, which again you're probably familiar with, but good to review. Here's a little jingle to kind of help you with it. So you first underline the digit, look next door. Okay, so whatever digit they want you to round to, make sure you try to underline it. So let's say we were trying to round 459 versus 451. Okay, and let's say we want to round to the nearest tens digit for both of them. Okay, so for the first one, the first step, they say underline the digit. So I need to look for the tens digit, which is where the 5 is in both cases. Underline the digit, look next door. So we're looking right here, next door, to the right. If it's 5 or greater, add one more. Okay, so this one is 5 or greater. 9 is greater than 5. So we're going to bump it up we're going to add one more to the value that we had underlined. So your answer would become 460 because 9 is so close to 460. It's only one away. So that's why we bump it up to 460. Okay? If it's less than 5, like the 1 for example, you leave it for sure. So we just leave it as it is, and it becomes 450 as that answer because 1 is so close to 450. Everything after is a 0, no more. So if you notice, both end with a 0. Okay, so rounding it to the nearest tens means that your last kind of non-zero digit would be in the tens place value. Okay, so we'll read this again. Underline the digit, look next door. If it's 5 or greater, add one more. If it's less than 5, leave it for sure. Just leave it as it is. And everything after is a 0, not more. So just a 0. Okay? So again, if you need to copy this down into your notes, be sure to do that. All right, let's go on to some examples. First example, example 22 from the book. You need to round 376 and 4/10 to the nearest A, the integer, or B, 10. When they say integer, it's basically the ones place, okay? Because that's where your integers begin. So it's the ones place. Go ahead and pause the video and try that on your own first. All right, so rounding to the nearest integer, let's go ahead and rewrite this problem. Remember, we're going to underline that place value. The nearest ones place is the 6. We're going to look next door. 4. If it's 5 or greater, we add one more. But it's not 5 or greater, so we leave it for sure. Okay, so we leave it as a 6. So it stays 376. And then remember, after that is zeros. So this is our final answer here. 376. Now we actually don't need to write this 0.0 part because we already have rounded it to the nearest integer. So actually the correct answer should be just 376. Okay? You actually don't add the 0.0 at the end because that would be if we had rounded it to the nearest tenth. So the last digit should be whatever the digit is, the place value that they want you to round to. So if it's the nearest integer, that should be the last place value, just 376. Okay, next one, round to the nearest 10. So let's rewrite it, 376 and 4/10. Underline the tens place. Look next door, it's a 6, it's 5 or greater, so we add one more. So instead of 3 and then 7, it's 3 and then 8. Okay, rounding to the nearest tens digit, we do need the 0 back there because if we don't have the 0, it would become 38, right? So we definitely need the 0 back there because it is serving a purpose to let us know that there's 0 ones, but we don't need the decimals afterwards. So this one gets rounded to 380. Okay, let's try the next one. The population of Oregon at a certain point in time was, what is this, 3,498,275. State the population correct to the nearest 100 and then nearest million. Go ahead and pause the video and try it on your own first. Okay, so the first one to the nearest hundreds. Let's recopy the problem down, the number. We have to underline the number in the hundredths, and then we look next door at the 7. We're always looking next door to the one that's just lower. It's 5 or more, so we're going to add one more. Copy everything back down. Instead of a 2, now it's a 3. Everything else is a 0. So to the nearest hundreds, your answer would be 3,498,300. Now let's talk about to the nearest million. Write down the number. Underline the number in the millions. Look next door. It's a 4. It's not 5 or more, so we keep it for sure. It's close, but not quite. So to the nearest million, it would just be 3 million. This is why we use approximations, because if someone just kind of wants to know an approximation of how many people live in Oregon, they don't care about this. If you say, oh, about 3,498,300 people live there, you're going to be like, huh? Just what's the estimate? If you say, oh, 3 million people. Okay, great. That's all I needed to know. Just need to know, like, how many? Approximately. I don't need to know down to however many people. Okay, let's go on to another problem. So example 24 now. Round 8 and let's see, how would we read that? It's 1, 2, 3, 4. Let's go back to our chart to see. 4 digits behind the decimal point. 1, 2, 3, 4. So it goes tenths, hundredths, thousandths, 10,000ths. Okay? So it kind of follows the whole numbers, except it doesn't have a ones. Tenths, hundredths, then thousandths, 10,000ths, and 100,000ths. So it kind of follows the same pattern, but not quite. Okay? So you would read this as 8 and 4,703 10,000ths. That's why people just say 8.4703, right? They don't have to sit there and be like, let me read this properly. Okay, so you need to round it to 1 decimal place and then 3 decimal places. Go ahead and pause the video and try it on your own first. All right, here's A. We're going to rewrite it to, if you're rounding to the 1 decimal place, you're going to underline the first decimal place, look to the neighbor, and it's 5 or more because it's 7, so we're going to move it up for sure, add 1 more. I'm rounding it to 1 decimal place, so I just keep it as that. I don't need to put zeros behind it because this is the first decimal place already. So rounded to 1 decimal place is 8 and 5 tenths. Okay, let's look at B now. To 3 decimal places. 3 decimal places, 1, 2, 3. This one right here. Look to the neighbor. It is less than 5. So we're going to keep it for sure. Keeping it is a 0. Now normally that 0 doesn't really do much for us because there's tons of zeros back here. But since it says to round to 3 decimal places, I do need that 0 in the 3rd decimal spot because they specifically asked for the 3rd decimal place. So we do need to have something there. So don't get rid of that 0 because of how they asked the question. All right. Now our last example, example 25. A says evaluate 3 and 4/7 times -2 and 1/15. So you actually want to find the answer. And it says round the answer to 4 decimal places. So once you find the answer, which will be in a fraction, you then want to change it to a decimal and then round it to 4 decimal places. So go ahead and pause the video, try that on your own first. All right, let me give myself more space here. All right, so let me rewrite the problem so I have it right in front of me. This negative belongs to the 2 and 1/15, so that's why there's a parentheses. Let's keep it there. All right, I need to multiply. So remember, multiplying is just multiplying across, top times top, bottom times bottom, but I have these mixed numbers, so I do need to change them into improper fraction. Let's do that. Remember, the shortcut is to multiply your denominator by your whole number, and then you add the numerator because that's your remainder. So we're going to do that, and we end up with 3 times 7, and then add 4. So 3 times 7 is 21, plus 4 is 25. So this becomes 25/7 times This is 2 times 15 plus the 1 remaining. 2 times 15 is 30 plus 1, so that's 31/15. Okay, now we can multiply across. Oof, let me use a calculator for that. 25 times 31. Yikes. That is 775. That's a negative times a positive, right? Positive times negative. Remember our rules. Positive times negative would be negative. And then 7 times 15 for the bottom. So we have 105 on the bottom. Okay, so it's 775 105ths. All right. We have to change it into a decimal. So I could change it into a mixed number, but then I have to change it into a decimal anyway. So I'm going to go ahead and just put that into my calculator. It's a negative answer, so let me make sure I put that there so I don't forget it. I take my numerator, 775. So let me write that down. 775 is going to be divided by 105 into my calculator. Okay, because it's numerator divided by denominator. 775 divided by 105, I get, this big number. Let me jot down as much as I can. 7.38095. 7.38095. And then let's put down a couple more. 7.38095. 23809. How about that? Oh, I don't even have room. 238. Let's just add that much. They want us to round to 4 decimal places. 1, 2, 3, 4. So I underline the 4th decimal place, look to its neighbor. It's a 5. 5 or more means that we have to add 1 more. So this is 7.38. Adding 1 more would just be 10, which would then add over here. Let me use a different color so you can see that. If I were to add 1 more here, that would be 10, right? So then this would become a 0, and then I would actually add 1 more over here, right? It's kind of like carrying the 1 over. So what happened would be this would become a 0, and this 1 would actually get 1. So then that's our answer. Rounded to the nearest, or to the 4 decimal places. 1, 2, 3, 4. And remember, even though the 4th decimal place is a 0, we have to keep it there because they wanted it to the 4 decimal places. Adding 9 bumped the other neighbor over to a 1.